Hi children, welcome to Vidyalakshmi YouTube channel. Today we are going to discuss the topic called as electricity. We'll go along with the introduction. So the basic thing is then the various types of charges we need to know. So we are having two types of charges. So then one is a positive charge and another one is a negative charge. So what is a positive charge? So you can call the protons as a positive charge and electrons as the negative charge. So these two, protons and electrons, we will be calling it as a subatomic particles. Whereas a proton, it is a positively charged particle, and electron, it is the negatively charged particles. Clear? So how many types of charges are there? We are having two types of charges. One is a positive charge and another one is the negative charge. So the protons will be calling it as a positive charge and the electrons will be calling it as a negative charge, and these two will be calling it as a subatomic particles. So the next one is the units of charge. So what is the unit of charge? The unit of charge is coulomb. A unit of charge is coulomb. And then, so in 1 coulomb of charge, how many number of electrons will be there? That we need to calculate. So by using the formula, Q is equal to N into E. Q is equal to N into E. In 1 coulomb, how many number of electrons you are going to calculate? That means if I need to calculate means, so we know, can just rearrange the formula. N is equal to Q by E. So N is equal to Q by E. So N will be equal to Q value is 1 coulomb by the charge of electron. We know that it will be equal to 1.6 into 10 to the power of minus 19 coulomb. So 1.6 into 10 to the power of minus 19 coulomb will be there. Here also coulomb is there. Here also can coulomb. We can cancel each other. So remaining what will be then? 1 by 1.6. So after simplifying this one, you'll be getting it as 0.625 into 10 to the power of plus 19. Why we got the plus 19 over here? When the 10 to the power of minus 19 is going to numerator, it will become as plus 19 over there. So after simplification, you can just write it as 6.25 into 10 to the power of plus 18 electrons. Clear? So in 1 coulomb of charge, how many number of electrons will be there? In 1 coulomb of charge, 6.25 into 10 to the power of 18 number of electrons will be there. So the next one is then types of materials. So we are going to divide the material into two categories. So one is a conductor and another one is the insulator. So what is a conductor? So whatever the material which is having the property to conduct the electricity. Clear? So the material which is having the property to conduct the electricity. So those materials will be calling them as the conductors. Those material will be calling them as the conductors. So why the conductors are allowing the electricity? Why? Because they will be having more amount of free electrons, or else you can call it as a loosely held electrons will be there. So for example, if you are taking a copper is a type of a conductor, right? So the next material is the insulators. So the insulators, we can also call them as the non-conductor. Insulator, we can also call them as the non-conductor. So these are the materials which obstruct the flow of current. That means obstruct in the sense which does not allow the flow of current in it. Why it is not allowing the flow of current? Because they don't have any free electrons. Clear? They do not have any free electrons. Example, if you are taking a rubber. So rubber is a type of a insulator. So the next one is the main topic. It is the electric current. So what is the meaning of the word electric current? So already we said that in case of a conductor only, the current will pass, right? So then that rate of flow of charges, that means you can call it as the moment of charge. Clear? So the rate of flow of charges in a conductor will be calling it as the electric current. So how we can write in the form of formulas? So current equal to charge by time taken. That means the current is going to flow, right? So the rate of flow of charges. So the charge is going to flow with respect to a certain time taken. This rate is mentioned over here, right? This rate is called as a time. So I is equal to Q by T. So here we can able to measure the current by using the device. We'll be calling it as a ammeter. So the ammeter is a device which is used to measure the current. If you are measuring that one means we'll be calling them as a physical quantity. So what is the basic thing we require in order to measure any type of physical quantity? We require a unit. So whenever you are going to measure any physical quantities, we require a unit over there. So what will be the unit of current? So the unit of current it is coulomb per second. Why we got it coulomb over here? Because in the numerator we are having charges there. So what is the unit of charge? The unit of charge is coulomb. And in denominator we are having time taken is there. What is the unit of time taken? The unit of time taken is second. So the unit of current is coulomb per second, or we can write it as the ampere. And next, how we can define the unit of current? So already we said that unit of current is ampere. So how we can define that one? So then what is the unit of current? We are saying that I is equal to Q by T. Here I represents current, Q represents charge, and T represents time taken. So what is the unit of current over here? Ampere. So this only are going to define now. What is the unit of charge? The unit of charge is coulomb. What is the unit of time taken? The unit of time taken is second. That means 1 ampere is defined as 1 coulomb of charge is flowing for 1 second in a conductor. Clear? So we will define that 1 ampere as 1 coulomb of charge is flowing for 1 second in a conductor is called as the 1 ampere. Clear? So 1 ampere is defined as when a charge of 1 coulomb flows through the conductor for 1 second. That is called as 1 ampere. And next, how to measure the current? Already I mentioned that we can measure the current by using the device called as the ammeter. So the ammeter is a device which we are using in order to measure the current. So where we need to connect the ammeter? Always the ammeter must want to be connected in series. Always ammeter must only be connected in series. Why we are connecting the ammeter in the form of a series means because in case of series combination, the flow of current is same. The flow of current is same. Because of this reason only we are connecting the ammeter in the form of a series. So the next thing is that electric potential. So what is the meaning of the word electric potential? So we are going to move the charge. For moving the charge we need to do a certain amount of work. So the amount of work is done in order to move a charge from an infinity point to a specific point. Clear? So the amount of work is done to move a charge from infinity point to a specific point is called as the electric potential. Clear? So what is the formula to calculate the electric potential? So the electric potential is equal to, so we are going to do a certain amount of work. So work done. For what we are doing that work? In order to move the charge. So the electric potential will be equal to work done by charge. So here also we can measure the electric potential. How we can measure? By using the device called as voltmeter. So if you are measuring that one means here also it required a unit. So what will be the unit of electric potential? The unit of electric potential is, in numerator we are having work is there. What is the unit of work? The unit of work is joule. And in denominator we are having charges there. Already we said that the unit of charge is coulomb. So then the unit of electric potential is joule per coulomb, or this one you can write it as volt, So next one is then how we can define the electric potential. So we said that what is the meaning of the word electric potential. Next we need to know how we can define the unit of electric potential. That means you are going to define 1 volt over here. So already we said that electric potential V is equal to W, that is work done by charge Q. V is equal to W by Q. What is the unit of electric potential? electric potential unit is volt. Electric potential unit is volt. What is the unit of work done? Unit of work done is joule. What is the unit of charge? Unit of charge is coulomb. So here we are going to define 1 volt. So 1 volt is defined as 1 joule of work is done in order to move a charge of 1 coulomb. So we are going to do a work of 1 joule in order to move a charge of 1 coulomb. That only will be calling it as 1 volt. So how will define 1 volt? 1 volt is defined as 1 joule of work is done. So for what we are doing that 1 joule of work? In order to move a charge. Yeah, in order to move a charge. How much number of charge we are going to move over here? We are going to move a charge of 1 coulomb. Yeah, that is called as the unit of the electric potential. Like this only, you need to define this one. Next, last, how we can measure the electric potential? By using what type of device we can measure? By using the device called as voltmeter. So the voltmeter is a device which is used to measure the electric potential. So always the voltmeter must want to be connected in parallel in a circuit. In case of ammeter, we said that ammeter must want to be connected in series, whereas a voltmeter must want to be connected in a parallel. And then why we are using the voltmeter in order to measure the electric potential? Why? Because it is having high resistance. Since it has high resistance, it takes only a feeble amount of current in it. What is the meaning of the word feeble over here? That means it takes a less amount of current. So the voltmeter can able to just consume only a less amount of current, and then where it must want to be connected means always the voltmeter must want to be connected in a parallel in the circuit. Yeah, okay children. I think the concept will be clear. If you like the video, just click the like button and subscribe the channel. Thank you.